The first law of thermodynamics talks about the law of conservation of energy. According to the first law, energy is neither created nor destroyed. It can only be transferred from one form to the other. And we learned that there are two ways energy can flow between two objects. It is by heat and or work. And we can represent this by writing delta E is equal to Q plus W. For any process, the energy lost by the system should be exactly equal to the energy gained by the surroundings or vice versa. We can represent this by the following equation. The delta E of the system is equal to minus delta E of the surroundings. If we bring both the terms on one side, we can write the change in internal energy of the system plus the change in internal energy of the surroundings, which is equal to the change in internal energy of the universe is equal to 0, which means for any process, the internal energy of the universe remains constant. The first law of thermodynamics should be obeyed by all processes. That is, you take any process or reaction, we can say that as the process occurs, the internal energy of the universe does not change. Then why some processes occur spontaneously in one direction while they are non-spontaneous in the reverse direction? To understand what I mean by that, let us first define what a spontaneous process is. A process is said to be spontaneous if it occurs on its own without a continuous input of energy from outside. Now, students have a couple of common misconceptions about spontaneous processes. One, spontaneous processes does not need any energy from outside at all. This is wrong. Spontaneous processes do require energy to start. This energy is called as activation energy. But once a spontaneous process starts, no further input of energy is needed. The second misconception that students usually have is that the spontaneous processes are really fast. This is also wrong. Spontaneous process does not mean that it is really fast. For example, rusting of iron is a spontaneous process. But as you all know, it takes forever for a piece of iron to rust. So, spontaneous processes do require energy to start, and spontaneous process does not mean it is fast. Let us now discuss some examples of spontaneous processes. Let us assume we have a container divided into two halves, and the two sides of the container are separated by a partition. We have 1 mole of ideal gas on the left hand side of the container, and the right hand side of the container is evacuated. Now, when we remove the partition, the gas particles spontaneously expand into the right hand side of the container until there are approximately equal number of particles on each side. That is, half a mole of gas particles on left hand side and half a mole on the right hand side. This gas expansion occurs spontaneously, that is, without any continuous support from outside. Now, let us look at the reverse process. If we take half a mole of gas on each side of the container, the gas particles on one side of the container do not spontaneously move to the other side. That is, the reverse process does not occur spontaneously. For both the processes, the internal energy of the universe remains constant. That is, both the processes obey the first law of thermodynamics, but the process is spontaneous in one direction and non-spontaneous in the opposite direction. Why is that? Example 2. Let us assume we have a block of iron at 100 degrees Celsius placed on another block of iron at 20 degrees Celsius. The heat energy flows from hot iron block to cold iron block until the temperatures of both the blocks become equal. If both iron blocks are same mass, the final temperature will be average of both the blocks, that is 60 degrees Celsius. Now let us look at the reverse process. We start with two iron blocks at 60 degrees Celsius and suddenly some heat flows from one block to the other. The block losing heat cools down to 20 degrees Celsius and the iron block gaining heat becomes 100 degrees Celsius. This process is not spontaneous. Again, both the processes obey the first law of thermodynamics. Then why is the forward process spontaneous while the reverse process is not spontaneous? At room temperature, if you take a piece of ice, it spontaneously melts into a puddle of water. However, if you take a puddle of water at room temperature, it does not spontaneously change into ice. Note that these changes are spontaneous only under certain conditions. For example, melting of ice into water is spontaneous at room temperature, but at minus 20 degrees Celsius, the reverse process is spontaneous. So whenever we are talking about spontaneity, we should always talk about the conditions at which this reaction is spontaneous. In all these three examples, the processes are spontaneous in one direction while non-spontaneous in the reverse. These three examples are so common that from our daily experience, we can tell in which direction the process occurs spontaneously. But let us say I give you the following chemical reaction and ask you in which direction the reaction is spontaneous under a given set of conditions. We cannot answer that question from experience. Therefore, if we can come up with a principle or a law that explains what factor determines the direction of spontaneity of a process, it would be very helpful to predict if a given chemical reaction occurs spontaneously under given set of conditions or not. So, the question arises, why under a given set of conditions certain processes occur spontaneously in one direction and are non-spontaneous in the reverse direction? What is the factor that can predict the direction of spontaneity of a certain process? We will discuss that in the next video.